Hello. The first lesson in Unit 7 is solving systems using substitution. Now let's quickly review Unit 6. In Unit 6, we solved systems by graphing, and we had 3 different types of problems. The most common type of problem we had is that when we graphed the lines, they intersected. When this happens, we say that we have one solution. And remember, we name that solution with its ordered pair, x, y. So wherever those two lines intersect or cross, we had to figure out what that point was. Every now and then, when we graphed two equations, they actually made the same line. When that happened, instead of having two lines, we just had one. And when that happened, we said that that system of equations has infinitely many solutions. So sometimes that would happen, that two equations ended up, they made the same line, and so instead of having two lines, you just have one, and that means that any point on that one line is a solution to both of those equations. Then the third type of problem we had is that we had two equations that gave us two lines that were parallel, and we know that parallel lines will never ever cross, so that means that there would be no solution. Because with a system of equations, we're looking for where the lines actually cross. And where they cross is the solution to the system. But sometimes they never cross, so that means there's no solution. So that was Unit 6, where we did a lot of graphing. And I know graphing is fun, you like it, but sometimes when we graph, it's difficult to tell exactly where the lines cross. Or even if they're going to cross or not. Maybe they cross, but it's way off of our graph. Maybe it's at a point like, 100,75. There's no way we would make a graph that big in order to make sure that those lines cross. So, luckily, we have 3 other methods of solving systems of equations. And this is what Unit 7 is all about. We're going to solve systems using these 3 other methods. And in this lesson, you're going to learn how to use the substitution method to solve systems of equations. So substitution is when we replace a variable with something that it is equal to. You've done this before. When I tell you that, x equals 5, and you put that in for x, that's substitution. You're replacing a variable with something that it is equal to. Now, a key hint that will help you is that you want to make sure one of the variables is by itself to begin with. That'll really help you out if one of the variables is already by itself. If it's not already by itself, if neither the x nor the y is already by itself at the beginning of the problem, you need to be able to get one of them to be by themselves. So we'll practice that. So a basic example of this, kind of like I already mentioned, is one that you've done before. So if you did your homework for this first day, preparing for Unit 7, you actually practiced substitution when you did problems like this. This was actually problem number 9 from that homework assignment. So you have this equation, 3x plus 2y equals 10, and it says that if x equals 6, find y. Well, you are substituting when you put 6 in place of x, because it says x equals 6. So you are replacing the variable x with the number that it's equal to, which is 6. And so when you did that, then you got 3 times 6 plus 2y equals 10. And you can actually figure out what y equals, because you can take that 3 times 6 is 18. And then you can take that 18 away from both sides. So that gives you 2y equals negative 8. And then you divide by 2, and you get that y equals negative 4. So we know that when x equals 6, y equals negative 4. And we didn't do this, but we could write that as an ordered pair. The solution to that equation is the ordered pair 6, negative 4. So we will be doing that with our systems of equations we will write these solutions as ordered pairs as we figure out what the x equals and what the y equals. So let's practice here with example 1. So in example 1, it tells you that y equals 3x and x plus 2y equals negative 21. So you can see that the y in this first equation is already by itself. That's a good thing. Remember I said up just above, one of the variables needs to be by itself. And y already is by itself. That's awesome. So since y equals 3x, we replace the y in the second equation with the 3x. So that's going to look like, let's see, we have the x to begin with, plus 2 times y, but y is 3x, and that's equal to negative 21. So now I just have this one equation that I just wrote, and there's only one variable, so I can work on getting that variable by itself. So let's see, we have x plus, well, 2 times 3x is 6x. That equals negative 21. And 1x plus 6x is 7x equals negative 21. And to get x by itself, I can divide by the 7. And so that means x equals negative 3. Okay, that's good, but I'm not done yet. I did a little bit of work here, but you don't want to stop until you know what both x and y are equal to. So if I know that x equals negative 3, what I can do now is I can use substitution again, and I'm going to put negative 3 in place of x, and I could do it into either one of the original equations, but I'm going to do it into the top one, because all I'm going to have to do to find y, it says y equals positive 3x. And since I know what x equals negative 3, then I can just say, well, y equals 3 times negative 3, because x was equal to negative 3. So that means y equals negative 9. So now I know what both x and y are equal to. And now I just finish the problem by writing my answer as an ordered pair. The x was negative 3, and the y was negative 9. And so that ordered pair is really my final answer. I just put boxes around the x and the y as I found them. Okay, so that's substitution. We knew what y was equal to. Y equaled 3x. So I put 3x in for y in the second equation. Okay, let's try example 2. Uh-oh. In example 2, neither one of the variables is by itself to begin with. That's kind of a bummer. It doesn't say that x equals something or that y equals something like it did in example 1. So what you need to be able to do is look at one of your equations, or really both of them, but you need to try to figure out how can you get one of the variables by itself. Well, in the first equation, we have this x that's almost by itself. There's nothing in front of it that I would have to divide by, so that's a good thing. It just has a 5y with it that I can get rid of. So we're going to take this first equation and we're going to get the x by itself. To do that, I need to subtract 5y. Subtract 5y. So I'm going to finish this over to the right. So this becomes x equals negative 5y. I like to write the variables first. And then minus 3. So now, all I did is I rewrote that first equation so that x was by itself. So now I know what x equals. X equals negative 5y minus 3. So now I can take that and put it in for x into the second equation. Because I know that, oops, what happened? There. So now I know that x equals negative 5y minus 3 Since that's what x equals, I'm going to put that in place of x in the second equation. So that's going to become, okay, it starts with a 3. So 3 times x. Well, x is negative 5y minus 3. Notice how I like to keep whatever I'm putting in for the variable, I like to put that in parentheses, because a lot of times we're going to have to distribute. So whatever x was equal to, which was negative 5y minus 3, I kept that in parentheses when I put it in for x. I think that'll be a good thing if you do that. So then I just copy the rest of that second equation down. It was a minus 2y and it equaled 8. Okay, so now I need to simplify the left side so that I can figure out what y equals, because now that's the only variable in that equation, and so I'm going to figure out what y equals. So 3 times negative 5y is negative 15y, and then 3 times a minus 3 is a minus 9, and then we have a minus 2y equals 8. Since the y's are on the same side, I can combine them. Negative 15y minus 2y is negative 17y. And then we still have a minus 9 equals 8. So now I'm going to work on getting that y by itself. So we're going to add 9 to both sides. So negative 17y equals, well, 8 plus 9 is 17. Well, this is going to turn out nice. Divide by negative 17. And now I know that y equals negative 1. I'm going to put a box around that, but I'm not done yet because I still need to know what x equals. So if y equals negative 1, well, I have some options. You can put that into either of the first two equations. You can put negative 1 in for y and figure out what x equals. Or I can just put it into this equation up here. Since I got the x by itself, I can just put negative 1 in for y, do a little bit of a math problem there, and figure out what x equals. So I'm going to do that. So x equals negative 5 times y, which was negative 1. Notice how, again, I kept it in parentheses. And then minus 3. Hopefully you can see that. There's a minus 3. And then we be careful with our negatives. We need to be careful with our negatives. So x equals, see, negative 5 times negative 1 is positive 5, and then minus 3. So, well, 5 minus 3 is 2. So x equals 2. I'll put a box around that. Now I'm ready to write my ordered pair. Just remember to put your x first. So even though we found y first, in our ordered pair, you need to put the x first, which is 2, and then the y, which was negative 1. So in green, that ordered pair there is my final answer. The ordered pair 2, negative 1 works in both of those equations. And I could always check my work. Like, you can go back to the original two equations, and you can put 2 in for x and negative 1 in for y, and it'll make both of the original equations true. Okay, let's try examples 3 and 4 just to get more practice with substitution. I hope you are liking it better than graphing. It tends to be a little bit quicker and usually a little bit easier. I like it a lot. Okay, so in example number 3, we have these two equations, 6x minus 2y equals negative 4, and y equals 3x plus 2. Well, that's nice. The second equation has y already by itself. It already tells me what y equals. It says y equals 3x plus 2. So that's nice. That means that I can just put 3x plus 2 into the other equation for y, because that's what y equals. So now I'm going to rewrite this first equation. The first equation is going to become 6x minus 2 times y. But instead of y, I'm putting 3x plus 2, because that's what y equals. And then finish out that first equation. The first equation equals negative 4. Okay, so now I solve this equation for x, because the only variable it has is x. So let's see, 6x, this is a negative 2 times 3x, which would be a negative 6x. It's also a negative 2 times a positive 2, as I distribute here. And so that's minus 4, and equals negative 4. Okay? Okay, now we want to simplify this left side. Well, 6x minus 6x is 0. Those go away. And so I'm left with negative 4 equals negative 4. Well, that's a true statement. Negative 4 equals negative 4. And if we have a true statement, this is going to be infinitely many solutions. Remember, sometimes when we graph, we start with two equations and they end up making the exact same line. And so this just happened with this system, but we didn't graph it. We just, tried solving it using substitution and came to this true statement. Our x's went away, and we had these two numbers that are really the same number. And so since that's a true statement, we say that this system has infinitely many solutions. If we were to graph it, you're more than welcome to pull out a piece of graph paper and graph these two equations. They would make the same line. These two equations would. So every now and then that happens, just like it happened every now and then when we graphed. Okay, let's try example 4. See what happens with that. In example 4, neither one of the equations starts out with one of the variables by itself. In the top you have 2x and plus 2y all on the same side. That's not by themselves. And on the bottom you have x plus y on the same side. So what we have to do is we have to get one of the variables by itself. The second equation is going to be easier. What you want to look for is you want to look for a variable that you don't see a number in front of it, and you can just get rid of the other variable that's on that side with it. So we actually have a choice to make. In this second equation, I could get the x by itself by just taking away the y, or I could get the y by itself by taking away the x. I don't think it's going to matter as far as one method being easier. Let's go ahead and just get y by itself, because we're kind of used to that. So if I get y by itself, that means I need to get rid of the x. So subtract x from both sides. So that'll give you that y equals negative x minus 2. So now you know what y equals. Y equals negative x minus 2. So now you can take that and put that in for y in the top equation. You have to do it to the other equation. So if y equals negative x minus 2, you're going to put that in for y in the top equation. So that'll give me 2x plus 2 times y, which is negative x minus 2, and it's equal to 8. So now I distribute. This gives me 2x. 2 times negative 1x would be negative 2x. 2 times negative 2 would be minus 4 equals 8. Uh-oh, what happens here? 2x plus negative 2x. Well, that gives me 0 again. So those will go away. But this time I'm left with negative 4 equals 8. And last time I checked, negative 4 does not equal 8. So that is false, and you're kind of used to this. Maybe you thought this was coming. Since that's false, that means that there's no solution. If we were to graph these two lines, they would be parallel, they would never ever cross, and so there's no solution to that system. They don't ever have a point in common. Okay? So again, just like with graphing, every now and then, infinitely many solutions and no solution could come up as your answer. It doesn't happen a lot, so if you're getting it to happen, like 2 or 3 times, you should probably check your work. But every now and then it happens. Okay, at this time, I want you to pause the video and try the on your own problems that are at the bottom of this page. When you're done with like problem number 5, then try playing the video and check your work to see how you're doing and if you're understanding this. So at this time, you should pause the video and try problem number 5 to check your work. Okay, so you should have done at least problem number 5 on your own. So maybe you're doing, problem number 5 and then checking it, and then pause it to do problem number 6 and then check it, and then pause it and do problem number 7 and check it. The idea is that you try these problems on your own and then come back and check them with me. So, in problem number 5, since x equaled 1 minus 4y, we already have x by itself. So you just put what x equals in place of x in the first problem. You're substituting that. So 2 times x, but x is 1 minus 4y, plus the 7y equals 3. Distribute. Combine your y's since they're on the same side. See, that's negative 8y plus 7y is negative 1y. And then get y by itself. So subtract 2. This is negative 1y equals 1. Divide by negative 1. So y equals negative 1. But remember, you're not done. You know what y equals, but you have to figure out what x equals so you can write the ordered pair. So now you're going to substitute that number in, and you could do it into either one of these equations, but I'll do it in the second one since it has the x all by itself. So I can just say that x equals 1 minus 4 times negative 1, because that's what y was equal to. So then x equals 1, let's see, minus, but 4 times negative 1 is negative 4, so that'll turn into plus. So that means x equals 5. And then your final step is to write that as an ordered pair, and that would be the solution 5 comma negative 1. So that's what you should have gotten for number 5. If you have any questions, please raise your hand and ask. Or if you're at home doing this, ask me tomorrow. At this time, if you haven't done number 6, pause the video, try number 6, and then come back and check it. With number 6, both of the equations have y by themselves. So this is actually going to be nice, even though at first you might be a little confused. Since both of them have y by themselves, what I'm going to do is I'm just going to take whatever the first one is equal to. It says y equals 3x minus 8. Since that's what y equals, put that into the second equation for y. So it'll look like 3x minus 8 equals 4 minus x. And now you need to work on getting your x's on the same side. We haven't seen one of these in a while, but this is great practice as we are finishing up the first semester. This is really just a review of Unit 3 at this point, because now you're just trying to solve for x. So I would add this x to both sides. So that gives you 4x minus 8 equals 4. And then now you're working on getting that x by itself. Add the 8. Divide by the 4. So it says x equals 3. X equals 3. But remember, you're only halfway done. Well, maybe a little bit more. But you have to also figure out what y equals. You can put this x equals 3. You can put that into either one of the equations. I'm going to do it into that one. So y equals 4 minus x, but x equals 3. And so, well, that's just 4 minus 3, so y equals 1. And so the ordered pair is x equals 3 and then comma 1, because x was 3 and y was 1. And I could have put that the x equals 3, I could have put that into the top equation. You would have gotten 3 times 3, which is 9, minus 8, and 9 minus 8 is still 1. So you're going to get the same ordered pair no matter what equation you put it into. Alright, if you haven't done number 7, pause the video and do number 7 on your own. Alright, for number 7, neither one of the equations is already solved for a variable. We don't have an equation that tells me what x equals or what y equals, so I have to get one of them that way. If you look at the first equation, the x is almost by itself. In order to get x by itself, I would just have to add the 4y. So we are going to do that and get the x by itself. It would be the easiest thing to do here. So that will give me that x equals 4y plus 1. So now I know what x equals. X equals 4y plus 1. I'm going to put that in place of x in the second equation. So that gives me 2 parentheses 4y plus 1, because that's what x was equal to, minus 8y equals 2. Distribute, and you get, let's see, that's 8y plus 2 minus 8y equals 2. Well, this is another interesting one. 8y minus 8y is 0. Those will cancel. So you are left with 2 equals 2. So this is like, I think example 3 was, where we have the same number on both sides. That's a true statement. So that means that there are infinitely many solutions. Okay, now you are going to try the practice quiz.